Hello, everyone. I could describe this picture for you. It's very calm, serene. It's a picture of a temple of Angkor in Cambodia. It's called Taprom Temple. You can see there are 3 walls, but the main feature of this picture is a tree growing out of the stones in the middle of this temple. The picture is, again, I could describe this further. I can go on and describe all the aspects of this picture, but that would be missing the point. It's hinting at much more. It's hinting at people who lived here. It's hinting at the fact that this civilization was very likely ancient because it took a while for the tree to grow out of the stone. Instead, we should be asking questions like, what happened here? How come the people that lived here disappeared? How did they get there? My talk is not going to be about describing the engineering culture at Criteo. It's not going to be about delivering value quickly over delivering on time. It's not going to be about how Criteo massively invests in big R&D centers. You can see our Palo Alto building and our Paris rooftop over there. It's true. My talk is going to be about how we got to our current state, how we evolved our culture into what it is today, and the framework we used to make sure it continues to evolve and meet the growing needs of our growing organization. So before I dive in, let me introduce myself. My name is Mohsin. I currently lead the US engineering team at Criteo. Previously, I worked at a number of startups, like many of you guys, and companies like AOL, Netscape, SunPower, etc. I've been working at Criteo for over 2 years. And during this time, I've seen the R&D team grow a lot. We started with 12 people a couple of blocks from here. Now we've got 90 plus engineers and researchers in this building. We also, in this time, acquired an 80% engineering company as well, distributed over New York and Ann Arbor, and we had the task of integrating these teams into our engineering organization. And in this meantime, Criteo organization, the engineering organization, doubled in size to 550 engineers. I've also seen quite a few cultural changes. When I joined, there was a small team. We had a small team spirit in Palo Alto. Things were simple. It was agile. We were very focused, worked on a couple of small projects, but not everything was rosy. We had challenges with working with the remote Paris teams. We also had distrust of teams in Paris, and Paris teams had distrust of teams in Palo Alto. So there wasn't much of a shared culture and common practices with the larger Paris organization. It's of course very different today. We have a much more effective distributed organization where people have shared values, common tools, best practices. And there's a little bit of a sense of belonging to a larger Criteo organization and not just affinity to your teams. Let me also say a quick word about Criteo. So Criteo is a market leader in ad retargeting. And what this means is we observe users as they interact with e-commerce sites. We use machine learning to predict whether users are willing to buy or likely to buy products or not. And the folks who are likely to buy, we bid for those users and show them relevant ads. This makes it very efficient because we only show ads to people who are likely to buy. And it's also very efficient for the users themselves. As we're growing into new markets, we acquired a company called HookLogic. We're entered the brand advertising business as well. And another project that I'm particularly fond of is this universal catalog that we're building out here. It's probably one of the largest product catalogs out there. And it's getting enriched with all the data we have about all the products all over the web. Lastly, Criteo is global. We have 2,700 employees across 30 offices. Our engineering team is distributed over 3 large hubs, Paris, Palo Alto, and Ann Arbor. And we have over 550 engineers. So the question is, why does engineering culture matter? The best quote I could find to describe why it matters is what Steve Jobs said. A very strong foundation of talent and culture in a company is essential to making great products. I'd also like to share with you what I ran into as I tried to nail down the definition of an engineering culture. I did what everybody else would do. I Googled define engineering culture. And what I found was pages and pages of all the cool companies and how great their culture was. But I could not really pinpoint an actual definition of what is an engineering culture and what makes a good engineering culture. So I was left wondering, what is an engineering culture? Is it an environment that makes us feel productive? That's certainly part of it. Is it a shared set of values? Values are part of it, but it's more than that. It's assumptions we're making, tools we're using, practices we follow, and the processes we employ to get our work done. For example, in the early days of Criteo, we had a very efficient and production-grade Hadoop cluster. So the general practice for engineers who wanted to get code into production was write a MapReduce job and push it into production. Not every problem was a MapReduce problem, but because it was the most convenient thing to do, that's what the engineers did. Things are, of course, very different now. We have things like Mesos and other tools that we use to do those things. But my point is culture a set of unwritten rules that we all follow, how things get done? One could say that, but that's not a very satisfactory definition in my books. So here's what I'm proposing. Engineering culture is a process to make decentralized decisions. So by this definition, a good engineering culture would be when a process is efficient, when people largely agree with the decisions that are made. This last point is very important, and it's very tricky to get it right. For example, if you're arguing with somebody in another team about how to name your method as part of a code review, if you resolve this conflict by going to a common manager, that's not a distributed decision, it's a local decision. But if you use any other way to resolve that conflict, that's a small part of your culture. Some cultures say consistency is very important. Some cultures have strict, precise, automatically checked code guidelines. Some cultures don't care what you name your variables and what you name your methods. In our proposed definition, this is all okay, because it means there's no friction, no time lost, no need to ask your manager. And this definition can apply to a lot of decisions that all of us need to make every day, both big and small. For example, how do you make cross-team or cross-department decisions? How do teams decide their priorities? Is the work imposed from top down, or people decide their own work? Do they make the decision in a distributed way? Or how does it all work together? All of this is part of your engineering culture. So what I like about this definition is that the why part becomes very obvious. Because of the sheer number of decisions all of us need to make, making those decisions in a centralized manner does not scale if you want to go fast. For example, if the average number of reports per manager in your company is 5, and if you're taking decisions one level higher than you could, then you're essentially 5 times slower at making those decisions. So maybe my previous example of code reviews wasn't as relevant you might think, but you'll be surprised. There's a lot of teams out there where the dev manager is actually doing all the code reviews. Of course, you can't argue that if the whole team collaborated and did the code reviews, it would be a lot more efficient, a lot faster to get code to production than having a single point of failure, which is the dev manager. This point about going fast is very, very important, especially in the ad tech industry where things change very quickly, and if you don't adapt and evolve, you're out of business. The last point here is for people to understand the rationale and the reason behind a decision. So if you understand the decision and why it was made, because maybe you were part of it, maybe you were part of a group of people who made the decision, or perhaps you observed somebody else making a decision, you're more likely to defend it, advocate for it, adapt the decision than if it was handed down from the top. So how did we achieve our current culture? What is the recipe Criteo use to evolve our culture? Surprisingly, or unsurprisingly, it's very lightweight. We don't have a big process to change the culture. In fact, we don't think it's a good idea to have a centralized process to change the culture, because ultimately the culture is going to be about making changes in a distributed manner. So it makes sense for the evolution of culture to also be decentralized and distributed. The framework we use is a few institutions and a few values. The first and most important institution that we have is called the R&D think tank. The R&D think tank is a group of engineers, program managers, leads, HR business partners who meet every other week to discuss how can we get better at working together. There is no hierarchy in this group. There is no prerequisite, no seniority. Anybody can join. If you're a newcomer and you're interested in how we work, you can join this group. It was started by one of our founders who wanted to improve the collaboration across R&D. It's very simple how it works. Let's say you have an idea you want to propose, a small change in how we do things, no problem. You get a slot booked in the bi-weekly meeting, and you propose your idea. The think tank will listen. They will provide you feedback. They will provide you advice on how to gather more data. They might even pair you up with another person from the think tank to support you as you understand that change. The most important thing is they'll definitely ask you to come back when you have answers to the questions they've asked. And every 2 weeks, the think tank group meets together. They have a number of projects that they're working on, either proposed by somebody inside the think tank or somebody outside the think tank. And they talk about tracking the action items. They provide review the feedback, the guidance, and generally transform ideas into experiments that you can run on 1 or 2 small teams. Or sometimes the experiments need to be run on the larger team. That's okay too. Since we have 3 engineering hubs, we have 3 local instances of these think tanks. The second institution that we have in the company is called the Tech Leaders. It's a weekly meeting and a mailing group. The group contains all the senior managers in the R&D and key influencers across the R&D. You can introduce your ideas to this group by booking a slot in their weekly meeting or just sending an email to the group. This group will give you detailed and actionable feedback, just like the think tank. But the main reason why you might want to present to this group is because if they like your idea and if they're convinced by your idea, they might say, great, that's something we should try. It gives you a lot of credibility and resources to test your idea. It might even get more people to respond to your survey or participate in your experiment. About values now. So between institution and values, if I had to pick one, the values are surely more important. The institutions are here as a guidance to develop your idea further, to give it weight and credibility, and easy to turn into an experiment. But they are supporting structures. Ultimately, it's the values that are pushing people to develop and evolve the culture. And that's why it's very important. The first value we have, and probably the most important one, is called empowerment. By empowerment, I mean giving everyone the tools to make changes, even if those are big changes. This can be pretty tough because sometimes people want to change things that you don't want them to change. But that's part of the process of empowerment. One could argue that without empowerment, it's impossible to have a decentralized culture. Empowerment is what pushes all of us to become actors of cultures and not just consumers of the culture. Personally, I do a lot of interviews, and many of my candidates ask me, why do you work here? What do you like about working at Criteo? I typically have a 3-part answer. Number 1, I like the scale. Number 2, I like the impact because the company is very small. Every engineer's code matters, and you can have a large impact on our business. And number 3 is I like participating in this evolution of our culture because it's a shared objective, and that's the part that I enjoy the most. Some time ago, an engineer so I'll give you a couple of examples. Some time ago, an engineer in Palo Alto, he noticed that different teams had different levels of understanding of the Spark framework. So he said, okay, I'm going to do something about it. He got a bunch of people together and formed a Spark guild to share the best practices between the teams. When I joined Criteo 2 years ago, I noticed that the agile practices were very weak, and there was a lot of room for improvement. So I talked to a bunch of folks around, and we started a Criteo Agile Practitioners group right here in Palo Alto, whose job is to support all the teams, improving their practice iteration after iteration. So the other question is, how do you promote empowerment? First, it's explicitly rewarded in our performance reviews. If you work on an idea that nobody asked you to solve, you are recognized for it in your performance review, you might get a higher bonus. You might even get a promotion because of doing that. Secondly, it's very common for senior managers to continuously reinforce this message. For example, when the Criteo practitioner group, Agile Practitioner Group, wanted to get feedback on the ICs, they came to me and said, Mohsin, you've started the group, but we don't want any managers in this group for a little while. I said, that makes sense. You guys have the power to continue this group without me and kick out all the managers from the group. And that worked fine. There was no issues over there. Another one of our core values is to keep experimenting. It sounds easy because everybody's talking about agility, running experiments, A/B tests, short feedback loops. But by experimenting, I don't mean propose something to everyone and iterate until they agree with you. What I mean is do something at a smaller scale, start small, learn, and iterate. What we do in Criteo is we spend a lot of time thinking about something that's going to go to all of R&D. And that's why we start small, make sure we learn, we change the processes, we evolve them, but we never abandon an idea very quickly. Because most of the ideas don't necessarily work the first time. You have to kind of adapt them, pivot them, change them to make them work. And we have many examples inside the company where projects were started in a particular way. They didn't work on first round. They had to be changed in terms of how they were presented and sold to the company and sold to the team. And eventually they worked. Now I will give you a couple of examples on how this culture and this process has actually unfolded inside Criteo. So when you ask newcomers and people who leave Criteo what they like the most about being at Criteo, a program called the Voyager Program ranks pretty much at the top of that list. The Voyager Program is a way to quickly switch teams for a short period of time, typically 2 weeks, sometimes longer, and come back to your team after that. People who participate are called Voyagers. The word Voyager refers to someone who goes on a long trip. Historically, voyages were about going and discovering new land. At least to me, it makes me think of traveling far to explore new places and learn. And that's kind of the idea about the Voyager program. So the Voyager program, how did it start? It was purely a product of the think tank. About 4 years ago, the engineering organization was in a state of flux. People didn't trust each other. The team did not want to accept each other's code. Patches were not getting accepted. People had a trust problem between teams. So the initiative was started in the think tank to solve this very broad problem of making people work together. It quickly appeared that one of the main reasons, perhaps maybe not the biggest, but one of the main reasons was that people didn't trust each other because they didn't know each other. So the idea evolved into how can we get people to work together so they get to know each other and start to trust each other. Not sure exactly who proposed this idea, but in the think tank, but there's a guy called Nico who was a big champion of this idea, and he became essentially the main driver of this idea. So the goals of the program were spread best practices between teams, both backwards and forwards, combat the us versus them mentality by embedding people in other teams and making them work with each other. And also, it was also a way to facilitate mobility, which is very important to build collaboration within the teams. And mobility, what I mean by mobility is when people get bored or they're ready for a change from their current project, they want to change to another project. Typically, it's pretty risky. What the Voyager program does is make the risk lower because you can go to the other team and see what the environment is like before you decide if you're going to commit for a longer term on that project. During the maturation phase of this project in the think tank, a number of changes were made. Number one, we wanted to make it very easy to set up the Voyager. And we set up a very simple duration of 2 weeks, which matches our sprint cycle, so that teams don't really miss a person who leaves their team for a couple of weeks and comes back. And lastly, we wanted to make sure there's no disruptions as this process occurs. So what we agreed to do at that point was that the target team would decide the timing and the project for the Voyager. Another requirement they imposed was when the Voyager comes back, he cannot bring back code ownership, because you don't want to bring the code maintenance back into the source team. So the project was presented to the tech leaders next. They were a bit doubtful that it would work, but they said, okay, let's give it a shot, but they put in a couple of constraints. Number one, no more than one Voyager per person per year. Number two, to minimize the disruptions in each team, one in and one out at the same time. And with that, we tried it. Nicholas went to the all hands and spent a few minutes explaining the program to all of R&D. It quickly picked up pace because it was a good answer to many problems. He had already lined up a few Voyagers in advance, so it was pretty fast for us to experiment. Since then, we've had a lot of Voyagers. We've got a VP of engineering doing a Voyager in the sales team, an engineer going to an internal IT team for a Voyager. When we acquired HookLogic, which is an 80% company, to integrate that team, we did a ton of Voyagers between Palo Alto and Ann Arbor and Paris and Ann Arbor to infuse the culture and welcome the team into our environment. So Voyagers are now a big part of our culture. They're used heavily for pre-mobility, as I mentioned before. If you want to switch teams, you can actually go and try before you buy. You might even try to go to 2 different teams and decide what's a better fit, because sometimes you actually don't know if the team you're going to go to is going to be the right team for you. We're also using it in places when we're about to enter a new domain. So if a team, for example, there's a team in Palo Alto that wanted to use a new job scheduler. And they said, okay, well, in order for us to learn about the job schedule, we're going to send a Voyager to Paris in the team who developed the job scheduler and learn about the job schedule, so that when he comes back, we're able to properly use the scheduler in production. And the program has evolved now. The Voyager program is much more flexible. You can do 3 weeks Voyagers to US, for example. You can also do multiple Voyagers per year. It's grown. It's given us a lot of value. Let me give you a more recent example. This happened last year. So if you ask the current product-facing engineers today, what's the biggest development goals they have? Machine learning would definitely be in the top 3. So the Machine Learning Bootcamp is a program. It's to provide hands-on experience with machine learning tools and technologies as specifically applied to Criteo's problems. It's 1 quarter long. It has intensive courses taught by Criteo ML researchers and as well as external resources. So the bootcamp is very intense, but it's designed for highly motivated individuals who want to move, who want to grow their career, and at the same time provide value to Criteo. So how did it happen? So when the new leader of our research team joined, she started asking the questions like, how can Criteo improve the pace of ML experimentation? How can we innovate faster? As she dug into the problem, she found 3 constraints. Number 1, lack of bandwidth dedicated to ML experiments. Number 2, limited number of engineers actually had the knowledge and the skills to properly do machine learning code. And number 3, it was very difficult to hire machine learning engineers given the scarcity of ML talent. And even when you were able to hire people, it took a while to get them up to date on your tools and your processes. So the machine learning idea was born with these 3 goals. Address the machine learning bandwidth gap in terms of running more experiments so you could fail faster. Number 2, Criteo had a large body of systems engineers with good math and statistic backgrounds. And the idea was to invest in those engineers and grow their skills, and at the same time help Criteo run more experiments. And lastly, to address the ML skill gap and not rely completely on exclusively on recruiting fresh talent, we decided we were going to just do it ourselves in-house. So then the proposal was sent directly to the tech leaders group. It skipped I guess instead of going through the think tank, the tech leaders suggested a number of improvements to improve the efficacy of the program, and then changes to attract senior engineers. So for example, they changed the curriculum a little bit. They changed the duration of the program. It was originally proposed to be 6 months long. We decided we're going to try with 3 months. And after those changes, we said, okay, we're going to try a few of these. We had 2 constraints. We started with 4 boot camps in the beginning on two different continents. And we also put a constraint in that no more than 1 person in a particular team can work on this boot camp to minimize the disruption to the team. Rollout. Then we tried it. Suju is the head of our research. She went to the all hands. She had already pre-selected a few people who were ready to join the program, and she introduced the idea to the rest of the organization. It quickly gained pace because it solved a major skill gap in our organization. Since then, we've had about 20 boot campers who've gone through the program. We've had people who've changed careers from engineering to data science, and in some cases from engineering to ML engineering. But a lot more people have come back into the teams and actually shared a lot of the machine learning practices that they've gathered in the bootcamp. We also have a number of ideas developed that have gone on our product roadmap. We're currently working on an MVP in Palo Alto, which was basically based on, the product is not yet announced, but it's based on the research done by one of the boot campers. So the ML bootcamp is now a very important part of our culture. It's used by ICs, for example, when they have an idea and they want to actually push that idea, they apply for a bootcamp and get 3 months to work on their idea. Initial bootcamp has tweaked quite a bit. Initially it was very intense. People had to work nights and weekends. We've kind of pared it down a little bit to make sure people can actually properly learn. And we've increased our capacity to do boot camps. We can now take on 9 boot campers every quarter. So as I said in my introduction, I didn't want to describe to you what our engineering culture is. These were just 2 examples. Ultimately, we were trying to solve our own problems, and you will need to try to solve your own problems as well. Maybe your problems are similar, maybe they're not. The main point is that the framework is much more important than copying and pasting what has worked for us. So going through the process is what matters. But don't misunderstand me. I'm not saying that let your culture grow organically without really paying attention, because culture is going to grow like habits. People are going to do what they need to do to get their work done. But it's very important for you to build the right culture, and getting it right takes time, because it's like forming habits. It's going to be a long and iterative process, so you better start early. The other important factor for making sure this happens correctly in your company is for the senior management to make it a high priority very early in the company's life to make sure there's a good engineering culture. But it's not only their responsibility, it's the responsibility for all of us to groom and nurture the culture. The main role, I would say, for the senior leadership is to create the framework to nurture the culture. And most probably, the framework they're going to use is going to have institution and values like ours. But as I said before, the values are the most important. And strong commitment at all levels to personify those values is probably the most important thing, because people follow what influential people are doing. And culture will grow around the behaviors of influential people. So it's very important for the key people to actually personify the values properly. Before I conclude, are there any questions on what I've covered so far? Went pretty fast over a lot of material. No questions? Yeah.
Are you using Coursera for the email bootcamp or not?
In a limited case. A lot of our courses are interactive because it's a very immersive experience and people don't necessarily want to go to Coursera. It takes too long. We're trying to get a lot of stuff done in 1 quarter, so it's 6 weeks of pretty intensive training done by ML researchers for the most part. But people are welcome to try Coursera prior to joining the bootcamp. Any other questions? Okay. So before I close the session, I want to make my final point. Culture is going to evolve anyways. Like this tree that grew out of the stone, culture is going to evolve. It's going to fill the holes and form new habits. Your problems will change and your solutions will need to be adapted. But I think if you put in a framework in place, you can be confident that the culture will be cohesive and it's going to grow in the way you want it to grow. Even the institutions we put in place, they had to evolve with the culture. So when we started, we had 1 think tank in Paris. Now we have 3 engineering hubs, and we have 3 different think tanks. And one of the questions we're trying to figure out right now is, how do these 3 think tanks work together? Are they going to evolve engineering culture in 3 different directions, or are they going to bring it together? My hope is that the systems and processes we put in place is that we can ultimately solve our own problems and bring them all together. I'm sorry I have to insert the mandatory hiring slide. We are hiring in Palo Alto, Paris, and Ann Arbor. Thank you. I'm going to be around if you have other questions.